Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is maximum product between two pairs. So let's go to LeetCode. Alright, so the product difference between two pairs AB and CD, these are two pairs, is defined as A into B minus C into D. For example, the product difference between 5, 6 and 2, 7 is basically multiply 5 and 6 and then subtract 2 into 7 from that. So given an integer array called nums, choose 4 distinct w, x, y, and z such that the product difference between the pairs, these numbers that you're going to choose from the num, it's maximized, right? So now we need to return the maximum product of product difference. Clear? Easy peasy. Now, how do we actually choose these for integers? By the way, in the constraint they have given that these numbers are going to be positive. If they were negative, that would make another interesting story, but here they are all positive, so I think that will make our problem quite easy. So we need to choose 4 distinct integers, they can't be same, and basically find the maximum product difference. So what do you think, like, in order to get the maximum product difference, shouldn't I choose two maximums, so let's say A and B, and then I should choose two minimum nums, C and D, and then I basically multiply these two minus C into D. That will give me the maximum product, right? Maximum product. What do you think? Doesn't that hold true? I think it does, because all the numbers are positive. If you choose two biggest numbers, multiply them, and then you choose two minimum numbers, two smallest numbers, and then you multiply them, and then subtract the product of smallest number from the product of two largest numbers, then you get the maximum product, right? So in this particular case, if I choose what are the two largest numbers? 6 and 7. So I'll do 6 into 7 minus what are the smallest numbers? 2 and 4. So 2 into 4, this will give me 42 minus 6, that gives me 36. So that will be my answer. Does that give me 36 or 34? Oh, so this is not 6, this is 8, so this gives me 34, so my bad. So this will be 30, yes, 2 into 4 is 8, so this gives me 34. So that is my answer. So the problem is easy, right? How do we choose these 4 numbers, 2 maximum, 2 minimums, by going through our nums? Well, what I feel is, why don't we have these variables for 2 smallest numbers and 2 biggest numbers, and then when at every number that I see in my nums, I basically decide if this is larger than my the greatest number that I've chosen, these two numbers that I've chosen. If it is larger than my biggest number, then I will assign my biggest number that number, but my second biggest number become the first biggest number before I do that. So you know what, let me make it very, very clear. Let's just do this. So initially what I'll do is I will declare let's say largest number, so I'll call it let's say biggest 1. Initially I'm gonna say this biggest one is 0, yeah. Then biggest 2 is also 0, and then I'm gonna call smallest 1 is gonna be I think for smallest we should choose the largest number so that we can decrease it, so I'm gonna call it infinity. Then smallest 2 is also infinity. Now we're gonna go through our array. So I come across 5. So I'm gonna check inside these if else statement that I'm going to have inside my for loop. Is 5 greater than my biggest one? Yes, it is. So what I'll do is I will assign my biggest number. So what I'll do is at this point they're both 0, but logically if I'm finding the biggest number, so which will be bigger than the first number, so biggest one, it's bigger than biggest one. So before I basically assign this new number which is like greater than that to my biggest one, I would rather assign this number to my biggest 2, because this number was already bigger than biggest 2. So let's say in some scenario this was I'll show you guys, like, so I'll assign this 0 here, and then I will turn this 5. Okay, turn this 5. Then what is my smallest one? I will also have to calculate my smallest one. So right now my smallest one is also 5, right? Now I come across 6. Is 6 greater than my biggest one? Yes, it is. What is my biggest 2? It's 0, but I don't want to lose this biggest. First time I saw 5, so what I'll do is I will assign this 5 before I place 6 onto the biggest one. Okay, this makes sense. Then smallest one is 5. Now smallest 2 is 6. Now I'll check, is my smallest one is lesser than 6? Yes, it is. What is my smallest 2? Is my smallest 2 lesser than 6? No, it is not. It is greater than 6. So what I'll do is I will remove this 6 and place 6 right here. Okay, now 2. Is 2 greater than my biggest one? No. Is 2 greater than my biggest 2? No. Is smallest one greater than my smaller than my 2? No, it is not. So what I'll do is I will place this 5 right here. I will place this 5 right here and then assign 2 right here. Then same thing again, 7. I will assign 7 here, but that 6 will come down to the biggest 2, 6. Then 7 here. Well, both numbers are actually smaller than 7, so nothing will happen here. Then 4. Well, both numbers are greater than 4, so I don't have to do anything with these numbers. But then here I see that smallest one is actually smaller than 4, but smallest 2 is actually greater than 4. So that is why I will replace this 5 with 4. 4. Okay, then we have found our 2 greatest and 2 smallest numbers. So let's call them 7 into 6 minus 2 into 4. 2 into 4, that is what I will be returning as my answer, and that holds true for all the numbers. So this will be of big of n time complexity and big of constant space time complexity. So this is great, right? This is great. All right. So I'm just gonna write it really nicely. 7 into 6 minus 4 into 2, which gives us 34. That is our answer. All right, so let's write our solution. As I said, I'm gonna call it biggest one, initially 0, biggest 2, also 0, smallest one. Now to write infinity, this is how you write it. So INF, and then smallest 2. Okay, right, so let's go over our numbers inside the nums. So for num in nums, if this num is greater than my biggest one, if it is greater than my biggest one, then what I'll do is my biggest 2 will be assigned biggest 1, and then my biggest 1 will be assigned this number, right? Otherwise I will check if this num is greater than my num2. This might happen that this number, currently biggest 1 is 5, biggest 2 is 2, then I'm seeing a number 3, then biggest 2 will be changed to 3 from 2. So this is what I'm doing here. So we will change this biggest 2 to the number. Okay, same thing applies to so there are no else cases here. There are no else cases because we want to update all these numbers based on their comparison between already existing their values in comparison to the current num that we are saying. So if this current num is lesser than my smallest one, okay, so if this is lesser than my smallest one, then what I'll do is I will assign my smallest two, the smallest one, and then I will give this smallest one my value num. Then one more thing, if so this might happen that right now, let's say smallest one is 5, maybe let's say smallest one is 0 and smallest one is 0 and smallest 2 is 3. Then you see number 2. Then you see that 2 is not smaller than the first number, but it is smaller than 3. So that is why if the num is actually smaller than smallest 2, then I will just simply change the smallest 2 to the number. Okay, finally we will return, if you can see the last statement. Finally what we want to do is we will have biggest 1 and biggest 2 minus biggest 1 and into biggest 2 minus smallest 1 and smallest 2 and smallest 2. All right, so that will be all. And here I hope this logic is right, and I think this is right, because let's imagine a scenario where they both are infinity. Then you see number 4, then you see that 4 is assigned to smallest 1, then you see number 3, then 3 is smaller than 4, so I assign 4 to second number and 3 to the first number. This I think I'm actually making a mistake here. While so if number is greater than biggest 1, then I'm supposed to update it. But if I'm updating 1, then I'm assigning the biggest 2, the number that was assigned to biggest 1. So if this is happening, I shouldn't be doing this, because otherwise I'm writing that number to biggest 1 and biggest 2, both of them. So I think I will, if I make this else if, then that fixes that issue. So I think I was wrong when I was saying like we don't need elif or else here. We do need elif so that we do not execute this one if we are basically executing this. If this doesn't execute, then this does execute. Okay, so the same thing we will do for the smallest one as well. And I think now it all looks good. Yeah, so now I think we can run it. So let's try to run it on the yes. Okay, so I'm gonna submit. So that's our entire code, and yeah, it's pretty efficient. So let's write down the time complexity is gonna be big of n, and then space complexity is gonna be 1, because we are not using any space. We are using these 4 variables, but who cares? It's constant. So now let's go back to AlgoYogi, mark this solved. See you guys later in the next problem. Until then, bye bye.